So a little position time graph review for the semester test. You will not be asked to do a lot of fancy stuff with position time graphs, but you should be able to interpret them and tell what's going on in different regions. So if we just look at each of these three graphs and trying to figure out what's going on in each of these graphs, just from a description point of view first. So in this first graph, we recognize that we've got position versus time. So I would break this graph up into three sections. Right here, in this first section, we are moving away from the origin at a constant speed. I know that because our position is increasing, and it's increasing at a steady rate, right? My slope is not changing, so my rate is not changing. So this is moving away at a steady rate. This is stopped. Our position is not changing with respect to time. Just go back to what's happening to your y. Your y is your position. What's happening to your position with respect to your time. So we're moving away at a constant rate. We are steady. We are moving towards at a constant rate, right? So with this one, we're moving towards at a constant rate. I know it's a constant rate because the slope is steady. The slope is positive here. The slope is negative here. We are moving away here. We are moving towards here at a similar speed, right? Because the slope magnitude is similar, right? That's about all we'd say with one like that. We could calculate the slope or the speed if we wanted to by the rise over the run and those sorts of things, but not as much the focus right now. All right, we look at the second graph. How is my position versus time changing? We are starting with a not much change in your position versus time. And then there's more changing position versus time. And then there's a lot of changing position versus time. So in this one, we start off going fairly slow and speed up, speed up, speed up. So this is an accelerating graph. We start off at almost zero because your slope is almost zero, and you are steadily increasing that slope over time. It kind of looks exponential because we are covering more and more ground every second. So here you're accelerating the whole time. Your velocity is increasing. This velocity is more than this velocity. This velocity is faster. This velocity is slower. They're all moving away. Right? And then our last graph, we look at this one and what's going on. We start off going fairly quickly away from the origin, so we're going pretty fast. And now our rise, our change is not as much here as it is here, and it's even less here, and it's flat here. So the easy word for what's happening right here is we are slowing down in this first section until our velocity right here is zero. Our position is at a maximum. We're the furthest away right there, but our velocity is zero. It kind of looks like a parabola there, right? It kind of looks like one of our projectiles. And now my velocity is zero here, and now we're coming back towards the origin with an increasing rate. So here we started going away fast, slowed down and stopped, and now we're coming back, and at the end, we're basically where we started again. So it's like you're running really fast, it's a turnaround, running fast again, right? Where you're slowing down in between. Right, so those would be some position time graphs. We should be able to interpret position time graphs.